Okay, guys, I think we can start now. So, good afternoon, everybody. So today I'm gonna explain Boolean logic operations. So here in this section, I'm gonna explain some instructions to do Boolean logic operations, like bit by bit or bitwise, bit by bit logic operation like AND, OR, XOR. You should be familiar. I'm gonna make a very quick revision, but you should be familiar with these logic operations, okay? To make it clear, what we are gonna do in this section is, for example, I have one byte here, I have another byte here, so I wanna do bit by bit logic operation. So 0 and 0, and then this is the result, 0 and 0. Sorry, bit and bit, whatever is a bit, 8, 0 or 1, it doesn't matter. So bit and bit, or bit, XOR, okay? So we wanna do here, these logic operations here between 2 bytes, or if we have words, we'll see bit by bit. Is that okay? This is one thing I'm gonna explain. So we need to know, number one, what instruction we have to do something like that. If you have byte and byte and you wanna do bit by bit logic operations, this is number one. Number two, you should also learn how can I use this something like that? How it is that useful, or how I can use it? It's very useful, as you will see right now. We're going to use it all the time, as you will see right now. Let's first make a very quick revision on AND, okay? AND. So here, this is how AND works, okay? If you have one bit is 0, and the other one is X here means whatever it is, okay? 0 or 1, it doesn't matter, 0 or 1, okay? So if one input is 0, regardless of the other bit, the output is 0 right away. This is how AND works, okay? Maybe you learn it a little bit differently, but if you look at the truth table you learned it before, it will be similar to what I'm explaining here. Also, if one bit is 1 and the other bit is X, the result is X, okay? What you mean? I mean, if this is 0, I'm gonna get 0. If this is 1, I'm gonna get 1. Is that okay? This is how XOR AND works. For OR, this is how OR works. If one bit is 1, regardless of the other bit, the output is 1. If one bit is 0, so the output should equal the same value like this one. Is that okay? For XOR, this is how XOR works. Okay, again, if you look at the truth table, you will see what I'm doing here is correct. But I want to explain it in this way, because as you will see right now, I need it this way. You will see right now, okay? But anyway, XOR, in XOR, if one bit is 0, okay, and the other one is X, the output is gonna be the same bit. So if this is 0, it's gonna become 0 here. If this is 1, I'm gonna get 1, okay? So, and if one bit here is 1, so I'm gonna get here, I'm gonna flip this bit. That means if this one is 0, I'm gonna get 1. If it is 1, I'm gonna get 0. Any question here? Again, I'm here, nothing is new. I'm just explaining how logic operation work, okay? Then I want to explain how they are useful, okay? They are very useful. We're going to use them all the time, okay? How we are going to use them? We are going to use them because, guys, let me write it here. All the time we're gonna do two main operations, guys. Okay, I explained it before, so I'm gonna go through it quickly. All the time we need to do something like that. For example, I have a byte, right? And I want to check some bits. For example, I want to check this bit. If this bit is 0 or 1, I want to check. It can be 1 bit or more. I'm just explaining here for 1 bit, but it can be 1 bit or more. So I just want to check some bits if they are 0 or 1. We already did that in the last lab, right? We did that because we wanted to know if the number is odd or even. You can also do it to know if the number is positive or negative. Okay, in chapter 3, we're gonna do it in a different way, because as I told you before, in chapter 3, we have here port H. Again, don't worry about the details. The details are coming. Okay, so we have port H here, and we have a switch. The switches here are connected to port H. You can see the switches here on the board. We have 8 switches here. Every switch is connected to one pin on port H. Okay, so port H is actually 8 pins. Okay, and we connect 8 switches as you see here. Okay, and then internally there are some hardware internally so that you have a byte here. This byte should have an address like a memory location similar to memory location. It's not a memory location for sure, but I'm saying it's similar to memory location. It has address and it is a byte, so you can read, you can write as we did before for a memory location, but for sure it's not a memory, right? But you can do the same thing like a memory location. You have address, you can load, you can store, you can do everything you did for memory location. Anyway, so, and then here in this byte, you have every bit here, every bit is gonna somehow connected to one switch, okay? And how it is connected, okay? So this is hardware, it's not your business, or we shouldn't care about it, okay? So this is just hardware. So what happens is, every time there is a 0 volt here, the hardware is gonna put here logic 0. Every time there is 5 volt here, the hardware is gonna put here 1, right? So in this case, for example, by the way, I'm gonna design the external circuit here so that, as you will see later in chapter 3, if the switch is connected, you are gonna actually put here 0 volt. And if the switch is open, you actually are gonna put here 5 volt. I'm gonna design the external circuit this way. That means if I check this bit and I find this bit 0, what it means? It means the switch is connected, right? This is which switch? This is switch, because I told you every switch is gonna have like a bit, a corresponding bit, okay? So if you forget the hardware and to try to look at it as a software or programming point of view, in programming, I just have a byte. This byte has address like a memory location. And all what I need to know, if you want to know if this is switch, for example, number 7, if you want to know the switch is connected or not, all what you want to know, I just want to see if this is 0 or 1. I want to check this bit. Is that okay? So again, this is the point here, guys. We don't have instructions for bits. We don't. All the instruction we have should work on bytes or words, right? So I have to work on a byte. So I have a byte here. And using this byte, I want to check some bits to see if the switch is connected or not. Is that okay, guys? Again, you can think about anything else, because actually, if this one is logic 0, that means the pin outside here has 0 volt. And if this one is logic 1, that means the pin has 5 volt. In this example, this 0 and 5 volts are coming from a switch, but they can come from anything else. It can come from like as a sensor or anything else, okay? Is that okay, guys? So this is example. We are gonna do it in chapter 3, very important. So in this case, I have a byte and I wanna check some bits, if these bits are 1s or 0s. Is that okay? Okay, so this is, to do that, here, that's what I'm saying here. We can use logic operations to do that. So here, logic operation can be used if you want to check if some bits are 0s or 1s, okay? Someone can tell me, but we already did that. Yes, we already did that using branch if clear and branch if set, if you remember. And branch if clear and branch if set can be used to check some bits, if they are 1s or 0s. Yes, we already did that. However, what I'm gonna do right now, I'm gonna explain it in a different way, or we're gonna use, here, yes, if you want to check some bits, you can use branch if clear, branch if set. Yes, you can do that, or you can use logic operation. To be more specific, we can use AND, as you will see later, AND logic. Okay, logic AND. So the other option you can use, it's okay, you can use this one, or you can use logic AND, as I'm going to explain right now. Okay, so someone can tell me, so why I may need logic AND instead of this one? The answer is, so someone can ask me, can I use this one all the time? Yes, you can use this one all the time. You may not need a logic AND. That's totally fine. However, The problem with this one, as I explained before, this branch is short. But if you use logic AND, as I'm going to explain right now, you can make the branch long. So this is one advantage here over this one. One more thing, very important, still you need to learn, and it's not difficult, still you need to learn how can you use logic AND to check some bits as we did here. Why? Because when I teach C language, in C language, we don't have branch if clear branch of set, and you have to do it this way using AND. Is that okay, guys? So I'm gonna explain. I'm gonna explain how can we use AND to do the same thing like branch if clear, branch if set. Any questions? Okay. So let me finish this one before I move this one. So here, this is the main idea. Okay. So look at logic. Look at the idea here. What is the idea? How can, if you have a byte, how can you use AND operation to check some bits? Look at the idea. The idea is very simple. So if you look here, guys, for example, I want to check this bit and I don't care about this bits. I just want to learn, or I want to know if this bit is 1 or 0, 1 or 0. Okay. So the way I'm going to do it is the bits I don't want to check. I'm going to do AND with zeros, And the bit I want to check, the bit or the bits I want to check, I'm going to put 1 in their position. So specifically in this example, I want to check this bit. So I'm going to end this bit with 1. I don't care about these ones. I'm going to end them with zeros. Why? What is the logic? Why you are doing that? That's because when I end with 0, I told you I'm going to get zeros here. So it's like you are masking. So you mask this part, or you remove to this part, okay? So because I don't care about this part. So here, when you put zeros here, I'm gonna mask this part. So in the result, I'm gonna get a byte in the result here. This byte should have 0, 0, 0, 0, and then bit 7 and 1 should be bit 7. If you forget what I said, I'm gonna go back a couple of slides. Look here, guys. That is how AND works. The way AND works, if you want to clear some bit, just end it with 0, because 0 and anything is 0. That's why I selected AND, right? Also, if you 1 and X, I'm gonna get X. Is that okay? That's what I did here. So if you do here, if you end with 1 here and 0, 0, so I'm gonna get a byte this way. This byte has a bit of interest. I'm interested in this bit. Is that okay? And now it's not easy. You have a byte. It's not easy to check if the byte is equal to a certain value or not, because that's easy. I can do it. If you have a byte, you can check if this byte is equal to 5, to 7, to 0, whatever. Okay. And then after that, I'm gonna check if this byte is equal to 0 or not. If this byte is equal to 0, that means this bit is 0, right? Because the only way that this byte is storing the number 0 is that all the bits are zeros, right? So now I'm going to check the whole byte, which is easy. That's what we have been doing for several lectures. I can check if this byte is equal to 0, that means the bit is equal to 0. Otherwise, if not, that means the bit is equal to 1. You agree with that? You understand the idea here? Okay, guys. Okay, so this is how I can do AND. So I'm going to tell you something interesting here, as you will see later. Okay, so number 1, I need to do AND operation. You have to select a good correct number here, and you have to do AND operation. This is number 1. Number 2, I need to compare to 0, and then I'm going to branch if it is equal or if it is not equal. Okay, so now I need 3 instructions, right? I need number 1, AND operation. Number 2, compare. Number 3, branch if equal or not equal. That's totally fine. If you want to do it this way, I'm totally fine. However, the compare here is redundant. You don't need compare. You can just do AND, and then you can branch if equal or not. Why? Because if the result is 0, automatically the AND operation is gonna set or clear the 0 flag. And branch of equal or not equal, as I told you before, they just need the 0 flag. You got what I'm saying? So actually, again, if you are confused, I'm totally fine. You can just use 3 instructions. You can do AND, compare, branch, I'm totally fine. However, keep in mind, compare here is redundant. You don't need it, okay? Because once you do AND, the AND operation itself is gonna set the 0 flag, right? So if the result is 0, the 0 flag is 1, okay? And that's all what I need here for branch of equal, not equal, is the 0 flag. Any question here, guys? I'm gonna give you for sure example, but this is the main idea. Any question here? Okay. Let's compare this idea to branch because I know maybe some students are gonna be a little bit confused here, but please listen to me. Here I'm saying the way you have to do it, guys, how you select this number. All what I said is the bits you don't want to check, you have to put zeros and explain to why. Because I want to cancel them. I want to cancel them. And then the bits I want to check, you have to put 1 under these bits so that I get these bits, and then I can check the whole byte. This is the main logic here. However, if you look at branch, if clear, branch, if set, you remember how it worked? Number 1, you have to put the address first, whatever memory, the address of the memory location or the port, as you will see later. And then here you have to put a mask, and then you have to put a label where you want to go. Is that okay? And I told you the way you have to do the mask here is, the way you have to do the mask is, the bits you are interested in, you put 1. The bits you are not interested in, you put zeros. Is that okay? So in this case, it's going to be the same like this one. So the mask here will be the same like this one because it's the same thing. The bits I want to check, I put 1. The bits I don't want to check, I'm going to put zeros. It's going to work this way. Is that okay? It's the same thing. Okay? But as I'm going to explain right now, it's not always the same thing, but not in this case. In case of when you manipulate some bits, not here. But here, yes, the way we did the mask here, because this is how we do the mask. When you do the mask, the bits you want to check, you put 1s in their positions. The bits you don't want to check, you put zeros. So it's the same logic here, like this one. Is that okay? But it's not going to be the same. Just give me a few minutes, but not in this case, another case. Okay, but in this case, it's okay. They are the same. Any questions? Okay, now let's move to the next point. I told you guys, we need logic operation to do 2 things. I can use it to check some bits. If some bits are zeros or 1s, I told you you can do it using branch if clear, branch if set. I'm totally fine. Or you can use AND. I told you, and using AND, you can make the branch long, but here, branch of clear, branch of set, the branch is short. So if you are okay with short branches, okay, use it. I'm not saying this is programming, right? As long as the program works, okay, I'm happy. I'm going to give you the full mark as long as it works, right? However, you still need to learn how can you do it using AND operation, because in C language, as I said, in C language, you don't have this one. You have to do it using AND operation. Okay, guys? This is how can you check some bits. Very important. We are going to do it all the time. Check some bits. Very important. Okay. Another thing here, you can also use the logic operation for bit manipulation. What do you mean by bit manipulation? What I mean by bit manipulation is I have a byte here. Again, I don't want to check. Here, I want to manipulate some bits. What do you mean by manipulate? I'm going to tell you. So I have a byte. For example, I'm going to select some bit. For example, this bit or bits, whatever you like. So for example, here I talk about 1 bit. So here I'm going to select 1 bit, and this bit I want to clear this bit and don't change the other bits. So I have a byte. I want to clear 1 bit and don't change the other bits. Is that okay? 1 or more, 1 bit or more. Okay. Or I want to set this bit and don't change the other ones. Or I want to flip this bit. That's what I mean by bit manipulation. So bit manipulation means you have a byte and you want to manipulate some bits. And manipulate here means you want to set, you want to clear, you want to flip some bits. And look how it is. They have to be together. You have to clear some bits and don't change the other bits. Okay, so you have to do the 2 things. Okay, so number 1, how this can be useful? How you have a byte, you are going to flip some bits, you are going to clear some bits. How is this going to be useful? It's going to be very useful. As I also told you before, I'm going to repeat it very quickly. You are going to use it all the time, guys. For example, here, we have here, we have, for example, port B, as I'm going to explain in chapter 3, port B. In port B, we have here, for example, I'm going to connect something like an LED, right? You know what is LED for sure. So if I put here 5 volt, so the current is going to go this way. You are going to turn it on. If you want to put here 0 volt, so this one is off. And we have 8 of them here. We have 8 LEDs here, okay? So all of them, every one of them is connected to one pin, physically connected here. So if you look at the connection here, it's connected, okay? Physically, it is connected to one pin on the microcontroller, okay? So that means if I want to turn the LED on, all what you have to do, just put 5 volt here, okay? If you want to turn it off, all what you have to do, you have to put 0 volt here, okay? So very easy, right? So I have to write a code, or I have to write an instruction to put 0 volt or 5 volt to turn it on and off. Okay, so the question is how I can do that. I'm going to tell you how you can do that. Okay, again, there is a byte here. This byte has a certain address, like a memory location, like it has a certain address, like a memory location. Every bit here connected here. Okay, every bit is connected to one pin. So every bit is hardware connected to one pin. So if I put here in this bit, if I put logic 0 here, if I put 0 logic, the hardware is gonna put here 0 volt. If I put here logic 1, the hardware is gonna put 5 volts. That's okay. So if you look at this from programming point of view, I have a byte. Okay. For example, I'm interested in this LED number 0, right? So I want to turn it on or off. That means I have to manipulate this bit. What about the other bits in this byte? The other bits I don't want to change because I want to just change this LED and I don't want to change the status of the other LEDs. Okay, I want to just one LED, I want to turn it on or off, and I don't want to change the other ones. So from programming point of view, how can you do something like that? How can you clear one bit and don't change the other bits? How can you set one bit in order to turn the LED on and also don't change the other bits? How you flip? If you flip one bit, you know what I mean by flip? I mean, if this bit is 1, I'm gonna make it 0. If it is 0, I'm gonna make it 1. Is that okay? As you will see in chapter, now you should understand, again, all what you have an address, like a memory location for a byte, and all what you have to do, just one bit, I want to put 1 or 0, okay, so that I can put here 5 volt or 0 volt, okay, to turn the LED on and off. Is that okay? As you will see in chapter 3, if I want to make like a flashing LED, you know the way I'm going to do it? The way you are going to do it, number 1, I'm going to flip this bit. So I'm going to flip one bit. For sure, I'm going to explain to you how can you flip one bit. Okay. Number 2, I'm going to wait 1 second. Okay. And then go back and repeat. This is how I can make it flashing. Right. So I'm going to flip. And then wait 1 second because I want to make flashing. I'm going to turn it on for 1 second, off for 1 second, on for 1 second, off for 1 second. I can do it this way. So this is an example to why sometimes I need to manipulate some bits. Okay, guys, is that any questions? Okay, there are other than this one, there are many other examples. Okay, for example, if you have a number like 8, this number 8, okay, you have some bits here for number 8, and you want to get, for example, the closest odd number. So I can manipulate this bit to put 1 here, because once I put here 1, so I'm going to get the closest odd number. You can do this way, right? There are other application other than just manipulate other application for manipulating bits. I think one of them is, if you look at the ASCII code, you have here, I think 60. If you for capital, for uppercase letters, I think all of them should have 60 here. For lowercase, they have 40. That means if you want to change a number from uppercase to lowercase, there's only one bit you can manipulate. Okay. Anyway, there are many other. Here I'm telling you other idea, other application other than but most of the time, honestly, we're gonna use this one. Okay. We're gonna we care about manipulating bits in order to turn an LED off and on and so on. Is that okay? So by the way, this maybe again, keep in mind, we just put 0 volt or 5 volt on one pin, right? So it depends on what you connect here. So in this case, I connect an LED. That's why when I put 5 volt, I turn it on. In other application, I can connect to something like a latch. I'm not sure if you are familiar with something like that, a latch. So and this latch is gonna, for example, open the door electronically, open the door or close the door, because this latch. Anyway, I'm not going to give you much details. I'm just giving you some ideas. So here, when I put 0 volt, so the door is closed. When I put 5 volt here, so the latch is going to open the door, something like that. Still, again, you put just 5 and 0, and then this 5 or 0 connected to something here. Okay, let's return to my point here. So my point here is we have. Yeah. So my point here, guys, as I explained, I have a byte and I need a way, I need a programming way to clear some bits, set some bits, flip some bits, and don't change the other bits. Okay, guys? Okay. So let me tell you how logic operation can be used to do that. Okay. So before I continue, let me tell you the conclusion. The conclusion of what I'm saying here. There are two things we're going to do it all the time. Very important. How can you check some bits? How can you manipulate some bits? Okay. And I told you we can do that using logic operations. So I already finished how can you check some bits. Now I'm going to see how can we manipulate some bits. And again, don't change the other bits. Okay. So now how can you set some bits? How can you clear some bits? How can you flip some bits? I'm going to tell you what operation you can use and why. I'm going to tell you why. If you want to set some bits, you have to set some bits. Don't change the other bits. You have to use OR, logic OR. All the time, all the time. If you want to clear some bits, you have to use logic AND. All the time, all the time. If you want to flip some bits, you have to use XOR here for flip. Okay? All the time, all the time. Why? I'm going to tell you why. Look, I'm going to go back one slide. Let's see how it works, and then you will figure it out by yourself. Okay. Look how it works here. Look here, guys. If I put 0 here, and then this is 1 bit, I'm going to get 0, right? And if I put 1 and 1 bit, I'm not going to change the bit. That's exactly what I need to clear some bits. Okay? So if you put 0 here, that means this bit, I'm going to clear it. If you put 1, so I'm not going to change this bit. This is how it works here. Makes sense? Now, let's look at this one. Use the same logic here. If I want to set bits, so I'm going to put 1 here, 1 or any bit, I'm going to get 1. Okay, so regardless of the value of this bit, 0, don't change the bits. So the bits you don't want to change, I have to put zeros here in the location of these bits. Okay, so that I don't change them. So zeros are not going to change the bits. 1 are going to set the bits. Here, I know a little bit confusing because I'm going to use different way here. Look, but if you understand this way, you're not going to be confused. Here, 0, here 0, don't change. Here 1, don't change. So if you don't want to change some bits here, you have to use 1. Okay, if you want to clear, you have to put 0 here. Here, don't change. So 0 means 0. Okay, 1 means you set. Let's look at XOR, what XOR is doing. Okay, this is 0 XOR X, I'm going to get X. That means 0, don't change like this one. So 0 is not going to change. 1 is going to flip, as you see here. Okay, so let's have example. Okay, guys. So let me tell you the conclusion, and then I'm going to tell you, I'm going to give you examples right now. Conclusion, guys, is very simple. If you have a byte, if I have a byte, for example, and I want to clear this bit, don't think about it. Clear means end. So the operation is end. Okay. But the way you have to do AND operation, and then you have the bit I want to clear, I have to put 0. And then the bits I don't want to change, I'm going to put once this way. So I'm going to put once here. And then the result will be the same like this byte, but the last bit is clear. And that's what I want to do. Is that okay? Let's look at OR. If I want to do something like that, if I want to set some bits, I'm going to give you the same example. So I have here a byte. I want to set this bit. I don't want to change the other bits. As I told you here, guys, 1 is going to set. 0 is not going to do any no change. So here I'm going to put zeros here, guys. Zeros, because zeros are not going to change these bits. If I put 1, for sure, this one is going to be 1. Everything will come here. So this is a byte. The byte I'm going to get here will be similar to this byte, but the last bit here is set. Is that okay? If you look at this one, I'm going to use the same idea, same logic. So you have here a byte. I want to flip this bit and don't change the other ones. Look how XOR works. For 0, no change. 1 means flip. That's what I'm going to do right now. So I'm going to put here 1 to flip this bit. And then I'm going to put 0 everywhere so that no change. So the byte I'm going to get here will be the same byte, exactly like this byte, but the last bit is flipped. Okay, here I'm explaining, guys, for 1 bit, but for sure you can, it's the same thing. You can extend it 2 bits, 3 bits, whatever you like. Okay, for example, if I want to clear 2 bits, I'm going to put 2 zeros. If I want to clear 3 bits, I'm going to put 3 zeros. Same thing here. If I want to set 2 bits, I'm going to put 2 ones, and so on. Any questions? Okay, that means, look here, guys, you can say true or false. That means, for example, if I put here, guys, 0, 0, 0, 0, 0, 0. So I'm going to clear everything. So I'm going to put 0. So this is equivalent to clear instruction. So you're going to clear the byte. So this will be equivalent to clear, right? Here, for example, if I put here 1, 1, 1, 1, 1, 1, 1, 1. So this is equivalent to complement instruction. Do you remember complement instruction when you flip all the bits? Yes, I can do that if you want. I'm not saying why. You can just use complement, but just want to tell you, you can put more than 1, right? Anyway, any questions? Okay, anyway, let's see. So now, that's what I explained here, guys. So now, again, I didn't teach instructions yet. All what I told you, we have 3 instructions, bit by bit, AND, OR, XOR. I explained how can we use them. Now I'm going to explain instruction. I'm going to give you examples, and that's it. Okay? So let's explain the instructions we have. So number 1, for AND. For AND, we have only 4 instructions, as you see here, guys. We have AND register A and memory location or immediate value. So you can put here, guys, memory location. You can put here memory location or immediate value. What this instruction is going to do is going to do bit by bit logic AND for 2 bytes, byte and byte. Register A is a byte, and then the immediate value you are putting here is another byte, or it can be also memory location. And again, when I say memory, that means it can be any format, any format of the memories I explained before, like 0,x, 0,x plus, everything I explained before for memory, like for example 1000, whatever it is. Okay, same thing. So the result is going to be stored in register A, and this is byte by byte. Also, we have AND B, same thing here for AND B, and the result is stored in register B, right? We have AND CC. You remember, we have the flag register. We call it CC register, flag register. Okay, so you can do this way. This is if you want to change some flags. For example, you have a carry flag. You want to set the carry flag, or you want to, no, sorry, for AND, for AND, you can only clear the carry flag. Okay, again, you can do this way, or I already explained the instruction before, if you remember, like I think set carry or clear carry, right? So you can do this way or that way. So that's all what we have. That means we don't have logic for a word, right? But that's not difficult. If I want to do it for a word, so I can do AND separately. So I can do AND here and I can do AND here. It works this time here. Why? because there is no something like a carry I have to consider. So I can separate them. You remember? But before it didn't work before when we tried to do addition, because if you do addition it cannot be separate, right? Because there may be a carry. But for logic operations here, okay, you can work with them separately. That means even if you have like 32 bits number, 32 bits, 4 bytes, I can, and I want to do AND operation. You can do AND here and here and here and here separately. So there is no carry as we did before. Yes. So yes, we don't have here one instruction to do AND for a word, but the way you can do it is you can do AND for 2 bytes, okay, separately. So you can use AND here 2 times. Now let's see what for OR, what instructions we have here for OR. Same thing for OR, guys, as you see here. Same instructions. So the same instructions we have here. We have just a similar instructions, exactly same thing. But this one is OR, this one is AND, but it's exactly same thing. Okay. So let's see XOR. What do we have here for XOR? Same instruction we have here for XOR. So it's the same first 2 instruction. However, we don't have XOR for CCR, right? So here you can do XOR, same thing, exactly. All of them are the same. But here AND, here OR, here XOR, right? Any question? That's all what we have. Any question, guys? So now I'm going to give you examples. So now what I did, guys, I explained the logic operations. We have the instructions here, right here. Explain how can we use them. Now I'm going to give you examples, and that's it. Any questions? Okay, so let's see a lot of examples here. The first example here, guys, here I can tell you clear. I want to clear the upper 4 bits in this byte, in the byte at memory location 56. Okay, so I want to clear the upper 4 bits in this byte. Okay, so again, do you have, can you first of all, the way you should think about clear, as long as you want to clear, so you have to use AND, right? Logic AND, that's totally fine. Okay, but I want to do logic AND for this byte. So this is the byte 56, right? And then I want to clear the upper 4 bits and don't change the other bits for sure. So the way I have to do it, I have to put here 0 0 0 0, and then I have to put 1 1 1 1, right? And then I'm going to get the result. Okay, so this result should have 0 0 0 0, and then the 4 bits will be the same here because I didn't change the 4 bits. And then this one has to go to this memory location. That's what I want to do, right? So you need to ask yourself, do I have an instruction to do this operation, memory location and immediate value? No, we don't. All what we have, if I go back, it has all of them has to be through. They should be through registers A and B, right? That's why number 1, I'm gonna load register A with 56, as you see here. So number 1, I'm gonna read the byte, and then I'm gonna do AND operation with this immediate value, as you see here, immediate value, the same 0 0 0 1 1 1. Okay, and don't forget the result you have now. The result is in register A. I'm gonna return it to this memory location. Any questions? Is that okay? Any question? Easy, right? Okay. Okay. Now I'm gonna tell you something more interesting than that. Okay. If you understood what I did, that's totally fine. You can use it this way. I'm totally fine. You can use this one this way. This is how can you clear some bits and don't change other bits. Okay. But I have something more interesting. I have something easier than that. That we have an instruction I'm going to teach right now. This instruction is called bit clear. Bit clear. So I can do all this. The 3 instructions here. I can do it using only 1 instruction. I love this instruction. If you ask me, I recommend to use this instruction because this is going to make the program shorter. Okay, and instead of writing 3 lines or 3 instructions, I can do it 1 instruction. So why not? Okay, so this we have an instruction. It's called B for bit clear. Bit clear. Okay, And then you have to put here the memory location, for example, 56. Is that okay? And then you have to put here a mask. In this, that's it. So I have to give me two things. This instruction does not work on registers. They only work for memory location. Okay. So number one, you have to put here address. So this instruction is expecting two operands. One operand here for you have to give the address of the byte. Okay. This is the address of the byte that you want to clear some bits, and then you have to give me a mask. This is similar to the mask I explained before. In this mask, you have to tell me which bits you want to clear and which bits you don't want to change. Is that okay? So the way you have to do this mask, guys, is similar to the mask you did before. So I'm gonna put here 1 1 1 1. Then I'm gonna put 0 0 0 0. Okay. Why 1 1 1? Because this is similar to branch if clear, branch if set. I explained before. Okay. When you put 1, so you are telling the instruction, I'm interested in this bit. So please clear it. You get what I'm saying? All the time, the bits you are interested in, just to put once, and this instruction is gonna clear them. I know this will confuse the student, but you need to think about it a little bit, guys. Look here, guys. If you wanna do AND operation, you have to put zeros here and you have to put ones here. Why? Because this is how AND works. AND works when you put 0 here, so the result is going to be 0. When you put 1, you are going to get the same bits here. This is how AND works, right? Because here you are doing AND operation, and this is how AND works. However, for bit clear, I'm not doing AND operation. So I want to tell, don't care about how it's going to be done. Don't care about it. Okay? Just the instruction needs to know what bits you wanna clear. Okay? And the way you are gonna do it similar to bit clear and bit set all the time. The bits you are interested in or the bits you wanna clear, you have to put ones in the position of these bits. Okay, guys? So don't be confused. Big difference between this one and this one. Here I put 0 because I'm doing AND operation. Here I'm putting 1 just to tell the instruction I'm interested in these bits. So always you put 1. And this is the same thing we did before for bit clear and bit set. Okay, guys? So again, I love this instruction. Because again, if you wanna, these 3 instructions are just equivalent to this instruction. Let me say it again, guys. Bit clear. Okay, then memory location or address, and then you put here the mask. In this mask, you have to tell me which bits you want me to change and which bits you don't want to change. Okay, so all the time, if you want to put a mask, this mask it has to be once. You have to put once in the positions of the bits you want to change. Okay, so this instruction are gonna change these bits, are gonna and not change to these bits, and it's gonna store the result here. I love this instruction because this instruction it's just 1 is equivalent to 3, and you can use it all the time. However, for C language, you are gonna do something similar to this one in C language. Okay, so I recommend, my advice to you, you can use this one all the time. So this one is okay. This one, it doesn't have any disadvantage. I told you branch if clear, it has a disadvantage that this is a short, right? So that's why I told you sometimes you need to use AND, because this one, it can make short branches, but this one does not have. Maybe the only disadvantage here, this only can be used for memory location. It cannot be used for any register, only for memory location. And that's actually what we need, what we're gonna need in chapter 3, because all the ports we have here, like the ports here, have addresses like memory location, right? So here I'm gonna put address like a memory location. Any question, guys? Okay, now I'm gonna do the same thing. Exactly, I'm gonna repeat what I did right now, guys. But instead of clear, I'm gonna give you example for set. How can you set some bits? Okay, so here I want to set bit number 7 in the byte at location 10. So this is the address. This is the location address. right? So this is address for a byte. This byte, I wanna set bit number 7 and don't change the other bits. Okay. So the way I'm gonna do it, guys, is as you see here, again, because you wanna set some bits, as I explained before, you have to use OR. Don't think about it. You have to use OR, as I explained before, right? So okay. So all what I have to do, guys, this is the byte at memory location 10, right? And this is bit number 7. This is bit number 7. I want to set this bit, so I have to put 1 here, okay? And I don't want to change the other bits. I have to put zeros. So the bit you wanna set, put 1. The bits you don't want to change, put zeros for sure. Make sure, because this sometimes confuses students. So they have to be 8 bits. Sometimes I'm lazy to write the 8 bits, okay? But this confuses students. So let me see here. This is okay. Okay, guys. So here, yes. So here, oh, that's what I have to do. I have to do OR operation, okay? And the bits I want to set, I have to put 1. Bits I don't want to change, to put zeros, okay? Again, why? Because if you see how OR works, this is how OR works. The way OR works is if you put 0, 0, you are gonna get the same bits back, the same bit. So the bits you don't change, you have to put 0. This is how it works, right? However, for AND, it has to be 1. For XOR, the bits you don't change, you have to put 0. This is how it works, right? Anyway, so and then after that, I have to do OR operation. So the byte I'm gonna get here is gonna be exactly the same bits are gonna come here, but I have 1 here, okay? And then I have to store it in this memory location. Again, I cannot do this instruction this way because I don't have an instruction to do OR operation for a memory location and immediate value. It has to be through a register, okay? Because this all the instructions we have right here. So that's why the way I did it is, this is the way I did. Number 1, I'm gonna read the byte. I'm gonna store it in register A, okay, guys? And then I'm gonna do OR operation, and then I'm gonna use this number here, 1000, because I want to set this one. I don't want to change the other ones here. As you know, in this course, if you want to write it in binary this way, totally fine. If you want to write in hexadecimal, yes, you can do in hexadecimal this way. So this is okay, this is okay, whatever you want to do it. So this one is going to do AND operation. Then I'm going to return the result back to memory location number 10 or location number 10. Okay, guys, any questions? Okay, easy, right? So, and also similar to what I did here for bit clear. Okay, so if you want to use OR operation, you can do this way. I'm totally fine. It's totally okay. However, we have an easier way. The easier way is we have an instruction like bit clear. Here it's called bit set. Similar to bit clear. Look how it works, guys. Here, this instruction is gonna set some bits and don't change some bits. Okay, so here you have similar to this one. You have to put here address, and then you have to tell me again. You have to put here a mask. You have to tell me which bit you want to set and which bits you don't want to change. Here I'm gonna put 1 here in bit number 7 because I want to set this bit and I don't want to change the other bits. That's why I'm gonna put zeros here. You can put it in binary this way, so you can put it in, or you can put it in hexadecimal. Both of them are okay. So this is similar to bit clear and bit set. And similar to what I said here, guys, my advice to you in assembly, just use this one all the time. Much easier, much easier. And there is, so you can just use this one all the time in assembly, okay? However, you still need to learn this one because that's what I'm gonna do in C language. I'm gonna do something similar to this one. Okay, any questions? So very easy, very easy. I explain how can you clear some bits using AND operation, and then I explain you can do it using one instruction. It's called bit clear. You should learn how can you use this instruction. You have to put this instruction should work on a byte. This byte should be like a memory location. So you have to give me here an address, the address of this byte, and then you have to tell me which bits you want to clear. So this one is gonna only clear, right? So here only clear. So here you put 1 is the bits you want to clear. This one only set. So you have to put here 1 in the position of the bits you want to set. Is that okay? Any question? Yes, you have question? Any questions? Okay, guys, very easy. Just bit set, bit clear. Very easy to set some bits. And you already know why sometimes I need to set some bits and clear some bits. Okay. Now let's go to the third thing. I told you before, bit manipulation means 3 things. Bit manipulation means set. How can you set bits? How can you clear bits? How can you flip bits? So now I'm gonna go to flip bits. Okay. Flip bits, as you see here, guys. And when I tell you I want to flip a bit, flip bit number 7 in this memory location. Okay, that means all what you have to do. So this is the byte at memory location number 10. I want to flip this bit. So flip means XOR. Don't think about it. You want to flip, so XOR. So I'm going to use XOR operation. But the way I'm going to do it, I want to flip this bit. I'm going to put 1 here. I don't want to change these bits. I'm going to put zeros. Why? Because that's how XOR works. So what I'm going to get here, guys, the same bits here are going to come here. Same bits are going to come here. And then this bit is going to be flipped. So it's going to be B7 flipped, right? And then I'm going to put it back in memory location number 10. However, we don't have an instruction to do exactly the same thing I explained here. We don't have an instruction to do XOR for a memory location. So it has to be through a register. And that's what I did here. So number 1 here, I have to read the byte. I have to do it. I am here. This is 80. 80 here is actually 1000000% binary, right? So you flip some bit here and then return the result back to 10. Okay, guys, any questions? However, we don't have here shortcut. So we don't have a shortcut like bit set and bit clear. Okay. So for flip, this is the only way we have in both C and assembly. So I don't have bit set or bit clear. And that's what I'm explaining here. So if you want to set some bits, you can use or logic or. The other option, you can use bit set. And I prefer this easy. Why I go this way? Just use this one, easy, right? And if you want to clear some bits, you can do use AND or logic AND, or you can just use bit clear. But if you want to flip some bits, you can use XOR, but there is no, we don't have like an instruction other than XOR here. Any questions? Okay, that's what I'm explaining, how bit set and bit clear works. So bit set and the bit clear, you have to put here a memory address, you have to put here a mask. In this mask, you have to put 1 in the position of the bits you want to clear. I give you just an example here. I already explained something close to this one. Again, here you have to put here a memory location. So as I said before, any format for memory, you can use it. So for example, you can use 0, x. For example, you got what I'm saying? You can use 1, x plus or 1 minus x, whatever. Okay. So any format I explained for memory before, you can just use it here. Okay. Just, I know some students are a little bit confused here, guys, because these 2 instructions are very close to each other. Look here, bit set, branch if set. Big difference between them. The spelling is close, but big difference. This is branch, right? You remember I explained this one before. So this one this one is used if you want to check some bits, and if these bits are set, you are gonna branch. Okay, this one, it's not a branch instruction. This one is gonna set some bits. Okay, same thing here. Bit clear, branch if clear. Okay, so what I'm saying, these 4 or every 2 instructions here are very, very close to each other in the writing, right? In the English. However, they are doing something completely different. These are branch instructions. These 2 instructions are gonna set or clear some bits. Any questions? So let's have more examples here, okay? And then I'm going to explain just more examples that's it, and this will be the end of this topic, okay? Okay, so let's have more examples so that you can understand the topic better. Look here, guys. I want to branch to next if bit number 7 of the byte at number 10 is 0. So here, I have, yeah, so a bit 0. So I want to check this bit. This is a byte at location 10. So 10 is the address. There is a byte there. I want to check this bit number 0. As I told you before, guys, here, this is bit 0 and this is bit 7, right? We are going to agree on that, okay? So when I say bit 0, you should understand this bit 0, right? So here, I want to check this bit, and if this bit is, I want to branch to next if this bit is 0, right? So I want to branch if it is 0. For sure, let's do the easy way, the very easy way. I can just say, guys, as we did in the last lab, as I explained before, I can say branch if clear, okay? And then here's the memory location number 10, and this is the mask. In the mask, I have to tell I'm interested in this bit. You can put this way, or this is number 1, or you can put it hexadecimal number 1, right? So you have to put 1 in the position of the bits you want to check. So I want to check this bit, and if this bit is clear, I want to branch it to next. Is that okay? So you can use this instruction. I'm totally fine. However, as I told you, this instruction, the main weakness in this instruction is only used for short. That's why I'm going to give you the other way. How can you use AND operation to do that? Let's see how I did AND operation, guys. As I told you before, the way I'm going to do AND, look here, guys. I wanna check this bit. So I'm gonna put 1 here in the position of this bit. I'm gonna put 0 everywhere. Why? What is the logic? Look here, guys. I don't want you to, that's why I'm explaining why I put this way. I don't want you to memorize. If you memorize, you will forget. But if you understand it, you'll never forget. Okay. So what I'm saying is that what is the logic? Why you put 0s here? I put 0s here because I don't care about these bits. So I want to make them 0s. Okay. I put here 1 because 1, B0 and 1, I'm going to get B0 here. So now I have a byte. This byte is B0 and then 0, 0, 0, 0, 0 everywhere, right? So this byte has one of 2 values. This byte either 0 as a byte, either 0 or 1. If the byte is 0, that means this bit is 0. If the byte is 1, that means this bit is 1. Is that okay? So all what I'm going to do, guys, after I do this AND operation, if you want to compare to 0 or 1, I'm totally fine. It's okay. But you don't need to do that, because after you do the AND operation, if the result is 0, the AND instruction itself is gonna set the 0 flag. So you can just use branch if equal or not equal. So let's see how it works. So the way you can do it, guys, you can read the byte load. You can read the byte at memory location number 10. And then I AND to this number. You can put this number in binary or hexadecimal, as I said. Don't forget the hashtag here, guys, because without hashtag, this will be considered a memory location address. With hashtag means immediate value, okay? And then now this instruction, if the result is 0, is gonna put 1 in the 0 flag. If the result is not 0, it's gonna put 0 in the 0 flag, right? That's why after this instruction, I can say branch if equal to next. Because branch if equal is going to branch if the 0 flag is 1, right? Again, if you're confused, you can put here 1 instruction, but you don't need it. You can say compare A to 0, for example. Okay, you can, if you want to do it. If you're still confused, okay, that's okay. It's just a redundant instruction. You can compare A to 0, but actually you don't need it. Okay, so again, you can do this way, or you can use branch if clear. Any questions here, guys? Okay. Yes. I can tell you my personal opinion. The problem, one time I was in the lab, okay, and this buzzer is connected to one pin in port T, and in order to make some sound, you have to put here 0 for some time, and then you put 1, 0, 1, 0, 1. You make like a square wave, okay? As I'm gonna explain next chapter. Is that okay? On bit, this is pin number 5, on BT5, port T pin number 5. Is that okay? So the way you have to do it is, you have a byte, which is port T, okay? And then I'm only interested in bit number 5, So in bit number 5 here, I have to put 1, 0. I have to put 1, 0 in order to make this sound. Is that okay? So some student wrote the program, I check the program, everything looks okay, but it's not working, there is no sound. So I checked it again, it doesn't work. I changed the board, it still doesn't work. You know what was the reason? The reason was he wrote it in binary, okay? But you have to be careful here. What he did is, it was like 0, 0, 0, I think 0, and then 0, 0, 0, 0. Where is bit number? So this is bit 0, bit 1, bit 2, bit 3, bit 4, and this bit 5. So he had to put the 1 here, right? But what he did, he put, I think the 1 was here, or he didn't put 0 at the end, I guess. So, and he puts the 1 here somewhere, okay? So I didn't notice. If it is binary, it's going to be difficult to notice where is the 1 exactly. You got what I'm saying? So if you want to, if it is easier for you to use binary, I'm okay, but you have to be careful, don't make these mistakes. So what he did, he generated sound, but he applied it in BT4 or BT6, I don't remember, right? It was not on the same bit, because if you have just a bunch of zeros and the 1 somewhere, maybe it's hard for your eyes to see which location is it. So what I'm saying, if you want to do it in binary, because it may be easier for you, because for example, you know already, and I want to put here in 1 in this bit or 1 in this bit, because for example, if you want to, here the 1 is here, so this should be 0 and 8, right? 0, 8. If you want to do, but again, either way is okay if you want to do it in hexadecimal or binary. However, if you want to do binary, make sure you put the 1 in the correct location. I'm not sure if I answered your question. So there is no difference, okay? If you think hexadecimal, the only here, because I'm teaching, I want to tell you this 1 has to be here. That's why most of the time I use binary, right? But if just I give you this 1, you may not see exactly where is the 1, right? So, but also this is a good opportunity to tell you, I'm totally fine if you want to use binary, but you have to be careful, don't make this mistake, right? Make sure the 1 is in the correct location. Is that okay? So this 1 is okay, this 1 okay, whatever you want to use. Okay? So there is a minor problem here. Any question here, guys? To check some bits, always end. There are some things you don't even to think about it. As I said, if you want to check some bits, only end. Don't think about it's nothing else, only end. If you want to set some bits, or if you want to clear bits, and nothing else. If you want to flip, you have to use XOR. Is that okay? So, but there is a minor problem here. Okay, what is the minor problem here? The minor, do you remember what was the difference between compare and subtraction? You remember the difference between compare and subtraction? Yes, they are exactly the same thing. Both of them are going to subtract. However, we like compare more than subtraction, because subtraction is going to change the register. It's going to store the result in the register. Okay. So I don't want, so for example, if I say compare A to 0, right? So this one is going to subtract 0 from A, and it's not going to change A. And I need something like that, because I'm going to use A later in the program, because I'm not interested in the difference. I just want to update the flags. It's exactly the same thing here. We have the same problem here, guys. The same problem here, because this instruction here is going to update register A, right? So if you want to use A later, this instruction is going to change register A. So similar to the idea of subtraction and to compare, we have same thing here, okay? We have an instruction so that you can do AND operation, but the result is not stored anywhere, because I just want to update the flags. Is that okay? Again, if it's okay for you to change A, okay, I'm totally fine with that. Otherwise, if you want to do like compare, you want to just update the flags and don't change A, we have another instructions. This instruction is called bit A, and then you put here memory location or immediate value. So this instruction, guys, is going to do AND operation. It's going to update the flags, and is not going to store the result anywhere, similar to compare. So the result is not going to be stored in A, because you just want to compare. Okay, very interesting. Because this logic, think about it. This logic is similar to compare. I used to compare because I want to update the flags, because the branches needs the flags, right? I'm doing the same thing here. I'm using this and so that I update the flags because next instruction needs a flag. You know what I'm saying? 0 flag. So anyway, so here bit A, also this we have another one bit B. Okay, so these two instructions are exactly similar to AND, but you can see what is the difference between AND and between bit A. And look here, guys, is exactly same thing here. You do AND operation between register A and memory location or immediate value and updates the flags. Okay, and the result is not stored anywhere, but here the result has to be stored in A. Okay, so anyway, whatever. Any questions? Okay, let's have more examples. I have several examples here. I want to tell you something. For example, I have this pipe. I want to set 1 bit and I want to clear 1 bit. For example, so I want to set this one and I want to clear this one. You cannot do that using one instruction because keep in mind, I have one instruction to clear 1 bit or more. I have an instruction to set 1 bit or more. That means I have to use 2 instructions. Is that okay? So I can set this one and then I can use instruction for clear. Is that okay? So here I'm going to give you some examples here. I want to branch to next if I either bit 0 or bit 1 in memory location number 10 is 1. So here that means I have 2 bits here, guys. If if any one of them is 1, at least one of them is 1, so I'm going to branch to next. That means if you look at these 2 bits, guys, we have here, they can be 0, 0, or they can be 1, 0, or 0, 1, or 1, 1. This is all the cases, right? So it means if at least one of them is 1, I'm going to branch. So if these 2 bits are is storing one of these 3 cases, so I want to branch, right? Otherwise, I'm not going to branch. Is that okay? You got what I'm saying? So the way, how can I do something like that? Okay. So you can do it in different ways. You can check, for example, here, there is a difficult way and easy way. So let's think about it. Let's see the difficult way. The difficult way is I can check this bit. I can check this bit. If this bit is 1, I'm gonna go to next, right? As I'm telling you here. If not, so I'm gonna check next one. If this one, go to next. I can write it this way, okay? Or just long code, right? Or I can do it in a different way. Look how I'm gonna do it, guys. I'm gonna look for 0, 0. If this one is 0, 0, okay, that means you should not go to next. So okay, 0, 0 means if it is equal to 0. So here I'm gonna look the way I'm gonna do it. So here I'm gonna read the byte. I'm gonna do AND operation with 1, 1. Okay. So look here, guys. I'm gonna put here 1, 1, and 0, 0, 0 everywhere. So the byte I'm gonna get, this byte should have 0, 0, 0, 0, and then 0, 0, and then because of 1, 1, I'm gonna get bit 1. I'm gonna get bit 0. Is that okay? This is what I'm gonna get. Okay. Now, if I select branch if equal, so if this byte is equal to 0, that means there are 0, 0 here, right? If I select branch if equal. If I select branch if not equal, if this byte is not equal to 0, what it means? It means one of these cases, and that's exactly what I need in this problem. So that's what I did. So here I did. I did AND operation, and then I'm going to say if not equal, because not equal means one of these cases. Please go to next. Otherwise, just go this way. Okay, guys. Again, this is one way. I think the best way to understand it, this part is as I made here, as you see here. Look here, guys. Yeah, as I made it here. Okay, you can see this. Okay, I'm going to tell you another way, which is not easiest way, but I'm totally fine. So I can check bit by bit. For example, I can say I can use branch, or you can use AND, whatever you can do it. So for example, I can say branch if clear. Okay, I'm telling you here. Sorry, branch if set. So I'm going to check this one first. If this one is 1, go to next. If not, I'm going to check the next one. So look how I made it. I'm going to say branch if set, memory location number 10. Okay. And then I'm going to say %000000001. So if this bit is 1, please go to next. If not, it's going to come here. Okay. Now, if it comes here, I'm going to check the second one. I'm going to say branch if set 10. And then I'm going to say 00000010. So now I'm going to check this bit. If this bit is 1, go to next. So if the first bit is 1, it's going to go to next. If the second, otherwise, I'm going to choose the second one. If it is, I'm going to go to next here. If not, if you come here, that means both of them are zeros. Okay. You can do it in a different way. You can even say, look, I'm going to do it in another way. Look, a more interesting way. I'm going to look for the zeros instead of looking for the ones. I'm going to look for the zero. I'm going to say branch if clear, if it is clear. Okay. So if the 2 bits 00000011 go to, for example, here, go to a location, I'm going to call it end. And then, so if both of them are zeros, I'm going to come here to end here. If not, so next is here. Okay. So if both of them are not zeros, like this case, I'm going to come here. Otherwise, I'm not going to do this part. Okay. Confusing? Again, there are different ways. All of them are doing exactly the same thing, but in different ways. Okay. Yeah, so what I want to tell you here, branch if clear, if you look at 2 bits, that means this one is going to branch when the 2 bits are zeros. Otherwise means anything else like 0, 1, 1, 0, 1, 1. This all the possibilities we have. Don't branch. This one is going to branch if the 2 bits are ones. Otherwise, don't branch. Okay. Let's have more examples here. Branch if bit 0 and bit 1 equal to exactly this value 1, 0 in location 10. So here in the memory location number 10, I want to check these 2 bits. I want to branch if this is 1 and this is 0, right? Again, you have to use 2 instructions. I have to check bit by bit. That's exactly what I did here. So I checked the first bit here. If the first bit is 1, I think I made a mistake. It should be 1. Yeah, 0, 1. Okay. No. So here I'm going to check first. I'm going to check the first bit here, this bit. If this bit is 1, right, which is wrong, so I'm going to go outside. So I don't need to check the second one. So I'm going to check the first bit. If the first bit is 1, so just go to outside. So I don't need to check the second one, right? However, because this is a condition, this bit should be 0 and this bit should be 1. Okay. So I'm going to branch to a certain place. So anyway, and then, so if the first else, but so this branch is going to be taken if this one is 1. If it is 0, so the branch is not going to be taken, and then we are going to come here. When I come here, I'm going to check this. I'm going to check. I think I made a mistake here. This one should be 1 here and 0 here, because now I'm going to check the second bit, this bit. Okay. Now I'm going to check this bit. If this bit is 0, so I'm going to go outside. Okay. So here, if bit 0, I think I made a mistake here. This is bit 0. If bit 0 is equal to 0, I'm going to come this way. If bit 1 is equal to bit 1 is equal to 0, I'm going to come to here. Sorry, bit Z is equal to 1. Okay. So here I'm going to check the bit 0. If it is equal to 1 set, I'm going to come here. If not, so the only way to come to here is that these 2 branches are not taken. And these 2 branches are not going to be taken when B0 is equal to 1 and B1 is equal to 0. Okay, guys? It's not difficult, just think about it, okay? Let's have more examples. I think this is the last example. It's somehow very interesting example. I have it here in the slides. Let me go through. It's exactly the same thing, but I just put it in an application. So for example, here, I have a car, right? I have a car and I have this byte. I have this byte in this memory location. whatever it is. So a certain memory location 0, 0, whatever. Okay. And then this bit number 6 is gonna tell you if the left door is open or not. Bit number 5 is gonna tell you if the right door is open or not, right? So these 2 bits, I have 2 bits. If the door is open, it's gonna give you 1 or 0, I don't remember. But anyway, so you need just to check these 2 bits, to know if the door is open or closed. Is that okay? And then also we have here the cabin light. I think this is the cabin light. Yeah, I think, yeah. So this one for the light, for the cabin light. So if you put 1 here, you turn the light on, you turn 0, you put 0, turn the light off. You know, in your car, when you open the door, the light usually turns on when you open the door. Okay, so I want to do it here. So the way I'm going to do it, again, make it simple. I have 2 bits. I'm going to check these 2 bits. To know which door is open, if any. Which door is open, if any, right? This number 1. And then based on that, I'm going to make a decision. Either turn the light on or off. Okay? The good thing about this example, you are going to check some bits and manipulate some bits in the same example. Okay, so I'm going to show here. Just give me 1 second. For example, here. Yeah. So here, if you put 0, you turn the cabin light off. You put 1, you turn the cabin light on. And here you check bit number 5. If it is 1, that means right door is open. If bit number 6, if 1, that means left door is open. I'm going to just give you 1 example, and then I'm going to tell you next example next time, just to finish this part. So I'm just going to give you 1 second. So here, I want to turn the light on. So I want to put here 1 to turn the light on if the 2 doors are open. So here, I want to make it this way. If the 2 doors are open, that means if this one is 1 and this one is 1, I have to put 1 here. Otherwise put 0, right? Because open means 1. So this is the way I did. Look how I did it. Number 1, I'm going to say branch if set, and then I'm going to check these 2 bits. I'm going to check these 2 bits. That means if these 2 bits are 1s, that means that the 2 doors are open. That means I have to come to here to turn the light on. And this is how I can turn the light on. I'm going to use bit set to put 1 here in this bit. Otherwise, I'm going to come this way. Otherwise, it means the 2 doors are closed, or 1 door is open and the other one is closed. This is all the cases where in any of this case, I'm going to come here. Now I'm going to turn the light off using bit clear. So I'm going to put 0 to turn the light. And then I'm going to write here 1 instruction to skip this part to come to here. Okay. Anyway, I'm going to explain this example next time, but it's not difficult. Okay. I'm going to explain it next time before I start the stack. So next time I'm gonna teach stack. Okay. Thanks, guys.